Welcome back, everybody. So just as a little refresher about last time, so we talked about two things. We talked about the how to solve equations by doing the balancing things, like where you multiply and divide by numbers and add and subtract numbers to keep the equation balanced. And then we also talked about the square root property, so that you can take the square root of both sides of an equation and it remains balanced, it remains fair. And so the reason why we brought that up is because now we're going to talk about right triangles. And the Pythagorean theorem. Right triangle and the Pythagorean theorem, though if we were Greek, we would say the theorem of Pythagorean, the theorem of Pythagoras, if we wanted to be really, really pedantic. So draw a right triangle for a second. I'm going to highlight these things. The shorter sides, these are called the legs. And the longest side length here, this is called the hypotenuse. Mathematicians being mathematicians once again, trying to make exclusive language to make themselves feel better than everybody else. It's a true statement about mathematicians. We like to feel like we're better than everybody else. But the legs and the hypotenuse. So that's what they look like in like, so the answer is that the hypotenuse is always the longest side and the other two are the legs. But another way to think about it is that the legs equal the sides touching the right angle. And the hypotenuse is the side opposite the right angle. So the legs are the sides that touch the right angle, whereas the hypotenuse is the side opposite the right angle. And the hypotenuse is always the largest side length. So hypotenuse and the two legs. Now the formal statement, the way Pythagoras originally wrote it is very, very wordy. And so mathematicians, once algebra, like you got to remember, in the days of the Greeks, algebra had not been invented yet. Had it not been? I'm trying to remember my math history, because algebra was created in the Middle East, because algebra comes from the I think, and I'm going to butcher the word, but algebra is a Middle Eastern word. Oh, yeah, it's hidden. Sorry. No worries. Thank you for asking. So they might have had algebra at that point, but they weren't really talking to each other at that point. So maybe they were happening at the same time, but the Greeks didn't have algebra at the time, so their words, their definitions, their theorems were very, very lengthy and wordy. But once algebra was created, we were able to do this. The Pythagorean theorem, just to make it easy to write, I'm going to draw another right triangle. And I'm going to call the legs A and B. And the hypotenuse, I'm going to call C. So with a right triangle, what you can say is that the sum of the legs squared, the sum of the square of the legs is equal to the sum of, is equal to the hypotenuse squared. In mathematical language, that is saying the A squared plus B squared is equal to C squared. That is the theorem. leg squared plus leg squared is equal to hypotenuse squared. And then some notes. I meant to write notes, not note. First note is that this only works with right triangles. For any other triangle, scalene, acute, obtuse or acute triangles, it will not work. It only works for right triangles. And it's kind of one of the main axioms of our geometric system, of our Euclidean geometry, is that a squared plus b squared is equal to c squared. Now that's the important thing, but the other important note is that it does not matter which leg you call A or B, but C is always the hypotenuse. So when you're setting up these equations, C is always by itself. The hypotenuse is always by itself. But the legs, it doesn't matter which one you label A and B. I could have just as easily made the vertical line B and the horizontal line A. It does not matter, and that's because of the commutativity of addition, right? A squared plus B squared is the same thing as B squared plus A squared. So like it doesn't matter which one you put first. So that's the Pythagorean theorem. There's a lot of cool proofs that are provided. If you want to see them at some point, they're cutesy. And if you want to know why it works, please feel free to talk to me. But I'd like to just continue on and apply it. But there is a formal mathematical reason why it works, just in case you're curious. So find the missing side lengths. So part A, we're going to give you a triangle. And by we're, I mean I'm going to. And remember, these are not drawn to scale. So this is 9 on the bottom, 12 on the vertical, and then X on the side, on the hypotenuse. Part B, we're going to draw the triangle in a different orientation. Oh, we got to draw our little line to tell us that it is a triangle, or a right triangle. And for this one, the horizontal is going to be X, the vertical line is going to be 3, and the diagonal line is going to be 7. And part C, we're going to draw this one off kilter. I'm going to draw this first so I can get a perfect. And I'm going to tilt it like that, just to be special. 8, 11, and X. So those are our triangles, and we need to find the missing side length. And because we only have one missing side length, we can find it using the Pythagorean theorem. For the student who just came in, would you like to take a picture of the stuff? So this is what we've got. Yeah, of course. Did I tell you guys about one of the chemistry professors? Like my first semester here, so I was originally from I was originally teaching in Ohio, and they were running a very, very tight ship. Like they told me all the policies that they could do and like things you could do, you couldn't do. And then I get in and I'm teaching in the H building, which is usually the chemistry building. And there's a teacher in that department who's been here since pretty much when CSN founded. The guy's a dinosaur. So I'm getting ready, and his students are talking to him after class, and he says, like a student comes up and asks questions like, by the way, you should probably drop the class because I'm going to fail you since you took a picture. He didn't allow students to take pictures of his class. Crazy things. I was like, oh, okay, so that's the power that I have. I have that at my disposal. That could go to your head real quick. Of course, I would never do that. That's insane. But I mean, the dude was crazy. He always taught in the same room, and at one point he staged a sit out because he didn't get the room he wanted. Like legitimately, he just sat in that room and basically made the teacher who took the room move to a different room, which is insane. That's some dedication. So interesting dude, fascinating. I believe so. Yes. An older white gentleman. Which describes a lot of people. He teaches chemistry. By all accounts, he's a very nice guy, but just that weird, like very, very strict in his policies. Like my interactions with him have been nice, but that's maybe because I'm not a student. Maybe he just does not like his job. I recorded, right? We're not gonna tell anybody, so I'm keeping the name off the list, so we can't. If you want to know the name, wait until after the recording. Okay, so sorry, I get sidetracked. So you can either start to label them, like when you first start out, it doesn't hurt to do it, but as we go along, you don't need to do it as much. The legs are the ones that touch the right angle, so I'm going to call this one A and this one B, though you could just as easily label the first one B and the second one A. It does not matter, and then that means that the hypotenuse, the one that's opposite, is C. So the Pythagorean theorem says A squared plus B squared equals C squared. If you're having trouble memorizing these things, like if you rewrite the formula every time, it helps you memorize it. So you can rewrite A squared plus B squared equals C squared if you want. But it does not matter to me. So A squared, so 9 squared plus B squared, 12 squared, is equal to X squared. And I didn't expect you guys to have your perfect squares memorized, but that's 81 plus 144 equals X squared, and that gives us 225 is equal to X squared. And so now we have it as just a number equals our X value, but our X value is squared. So we're going to get rid of our little friend up top by undoing him. Since we squared, the opposite operation would be square rooting. So we'll take the square root of both sides. And yes, technically speaking, there should be a plus or a minus, but because we're dealing with a triangle, which has intrinsically positive measurements, we don't need to worry about the minus sign because we can't have a side length of negative numbers. But if you plug that into your calculator, or if you know your perfect squares up to your 20s, that's a perfect square. That's 15 squared. So you get that X is equal to 15. Or 15 is equal to X. It doesn't matter to me. I guess technically speaking, it's 15 equals X, but that's the same thing. And that's part B, or part A. And I didn't specify here, but round 2 decimal places. Round hundredths. Round to the nearest hundredth. 2 decimal places. So part B. I'm going to label them again, but as you get better at this, you don't need to. One of the side lengths is A, or one of the legs is A and B. Those are the ones that touch the right angles. So that's the top of the horizontal and the vertical. And then C is the hypotenuse, which would be 7 in this case. So that's A squared, so X squared plus B squared, which is 3 squared, is equal to C squared, so 7 squared. So let's simplify those, let's follow the order of operations and take care of those exponents. There's nothing we can do with the X squared yet, because that's unknown, but the 3 squared is 9, and the 7 squared is 49. And from here, I need to get the X by itself. So I take care of the furthest things away from it first. So that plus 9 needs to go. So I will subtract 9 from both sides, canceling it on the left. and getting x squared is equal to 40, at which point I will square root to cancel out the square and the square root and get that x is equal to the square root of 40, which if we're going to approximate it, so 6.32455 dot, but we're going to round to 2 decimal places. So we're rounding to the 100th right here. Looking at the digit to its right, it is a digit that is less than 5, so we will round down and say that our answer is 6.32. Any questions on that? Any part of it? I am tired. My son woke up like 10 times last night. Not a fan.
How old is he?
He is just about to turn 3. We put it like we had to move him from his original room was right next to the garage, and the garage has the water softener. And that flushes its system every night at like 3 a.m. and it's very loud. Scared him, and now he has night terrors about it. So and like every hat fell off of his dog, his little toy dog. It's like, I think the water softener did that. No, the water softener did not, son. No, the water softener can't hurt you anymore. You're in a new room that doesn't have it. But if it ever makes that sound again, he's a cute kid. Part C. So this time I'm not going to label them. I'm just going to set it up. So the legs are 8 and 11, whereas the hypotenuse is x. So this should be 11 squared plus 8 squared. Or you could do 8 squared plus 11 squared. It doesn't change anything. But the hypotenuse is always by itself, which we'll call x. But you can use any variable you want. If you want to label it as y or z or whatever, you can do that. 11 squared is 121. Plus 8 squared, which is 64. Equals x squared. Though if you want to skip that and just plug that into your calculator right away and get 185, you're more than welcome to do so. It's equal to x squared, at which point we square root it to cancel out the square and the square root on the right-hand side and get that x is equal to the square root of 185, excuse me, which is equal to 13.60147, on and on forever. So if we're going to round to the nearest 100th or 2 decimals, that would be to the 0 right here. But the number to the right of it is less than 5. So we'll round down to 13.60 or 13.6. Either way is fine. I did not draw an arrow. Sorry, I meant to write that. Yeah. Granted, I'm okay with that if you box 13.0 because it like that brings up a good point coming up to the exam next week. Couple things. So if you haven't already done so, there are textbook exercises at the end of each section. And then if you go to like when there's all the tiles in the on the bottom of the screen, like module 1, module 2, and module 3. If you click on that, it gives you a big list of all the sections, which has the note, like extra notes, the textbook exercises, but also gives you a worksheet along with the worksheet answers. So those are great tools for your review for the upcoming exam. And then when it comes to one of the classic questions that students will ask is, how much work do I need to show? It's a good question. And my response is, if you were to show it to a classmate who was a little less understanding of the material than you were, could they understand your work? And if so, if you look at it and you're like, no, like I've shown everything that's needed to make sure a friend would understand it, then that's probably sufficient. The other way I like to describe is, imagine I'm an alien who all I have in front of me is the notes in the textbook. I should be able to look at your work and say, I see how you got there. Does that make sense? So that is enough work. And the other reason why you should do it is because partial credit. Yes. Excellent question. Might as well take a small detour to show you. So let's go ahead and I'm going to stop sharing my screen. And then I'm going to share my screen on here. And this one, share. So this is like, you guys can already see this, with the people who watching the recording couldn't already. So on our nope. On our home page, where is it? Where are you guys? It's hidden there. Okay. On our home page, if it load for a second, come on, load the home page, please, and thank you. Of course, you're going to do this. Come on, what is going on? So you do have internet. What if I were to go to here and go? This is nothing. This is nothing. Like, you should see my wife. Like she has like 80 million windows. Come on. Okay, let's try and open it in a new window. Let's go to, come on. Can handle that. Oh, and how the people watching. Stop share, reshare. Which one is it? This one. There we go. Okay. Going to this. All right. So when you're here, so we're on the geometry module right now. That's like our first section. If I click here, it goes straight to the beginning. So it shows you the homework for 1.1. And then, but like 1.1 was just kind of a history lesson about the material. So we have videos here for all the material of 1.2, but then there's also a worksheet and the textbook exercises along with the worksheet answers. So you can click on those. There's one for each section. So for us right now, that's 1.2, 1.3, 1.4, and 1.5. So it's going to be 4 sections. Those are great things. And then the textbooks also, I believe, have answers to them at the end. So great tool for studying. Great tool. Is that okay? Any questions on that?
Our exam next week is going to be on sections 1.1 through 1.5.
Yes. All right. Get back to sharing it on my iPad. Thank you for asking about that. That's a good thing to mention. That should. There we go. Cool. We're all good. Okay. And the other thing, please don't ask me how many questions on the exam. I will always joke and tell you there's about 500. Because that joke never gets old to me. The answer is that I design my exams so that you guys have enough time. I've had a formula that I've catered, like that I've created over many years of doing this to figure out exactly how much time you guys need. And I like to make sure that you guys have enough time so that the average student could finish it up with more than 10 to 20 minutes to spare, so you can check your answers. So I promise you, like, I could make a 1-question exam that is way longer than a 15-question exam. So it doesn't really matter how many questions are on there. Pages wise, that's also something, like, depending on the types of problems, I might need to use more pages because I might need to use more graphics and things. So I promise you it will be doable within an hour and 20 minutes with time to spare. That's the way I design them. Anyways. It's going to be in class. It's going to be by written work. So show me as much work as you can so that you can get the most partial credit. Okay, cool. We're probably not going to finish 1.5 today, which is okay. And so we'll bleed that over, and then any leftover time we'll spend kind of doing some review problems that I've created. I'll bring in like a little worksheet, a little list of problems that I've created that are trying to kind of bring all the concepts together. So, anyways, any questions on Pythagorean theorem? All right. The next thing is trigonometry. Trigonometry.
We're still at 1.4.
Yes, we're
Okay.
still at 1.4. In general, for triangles, angles are represented by uppercase letters and side lengths are represented by lowercase letters. So in general, like most textbooks would agree with this. Mathematicians don't usually have too much consistency with each other, but one thing we typically do agree with is that angles are represented by capital letters or by Greek letters usually, like theta or gamma or things like that. And then side lengths are usually denoted by lowercase letters. In particular, side A is opposite angle A. Side B is opposite angle B, and side C is opposite angle capital C. And I'll show you what I mean in just a moment. The reason why I bring this up is this is going to be the most important thing for us to be able to solve trigonometric problems. We have to know what side corresponds to what angle. And you'll see why when we get to actually setting up trig. So the picture of this, I'm going to draw a decently large triangle. Specific for us for a right triangle. So I'm going to label this a capital A. I'm going to label that as a red A, excuse me. An A. That's the angle there. And then I'm going to highlight the opposite side in red. That is lowercase a. That is the side length A that is opposite angle A. Now, how do I know that it's opposite? Imagine if you were to draw an angle or like draw a line bisecting angle A straight out. The side length that you touch, that is the opposite angle or the opposite side. Similarly, this is angle B up top here. And then this means that the bottom is angle B or side length B, excuse me. Because you can draw a line straight out of B and it will touch that bottom angle or that bottom side length, excuse me. My angles to my sides swapped in my head. And last but not least is angle C, which for a right triangle, like in this case, it's a right angle, but so I'll even gonna make the box in green. But this would be side length C, because if you draw a line straight out from C, that is the side that you will touch first. that make sense? So the side lengths correspond to their they correspond to the opposite side of their angle. So that is the term opposite, but there's also the term adjacent. The hypotenuse is always the hypotenuse. I'll let you draw that first. That's a lot of coloring. So for angle A, I bring this up because depending on what angle you're looking at, the opposite side of it changes. So let's just draw that triangle again, that right triangle. We don't need to draw it as big. Once again, bottom left, capital A, top right, capital B, bottom left, capital C, right angle. And then this is A, B, and then C, like that. Lowercase a, lowercase b, and lowercase c. So for angle A, this is the opposite side. This is the hypotenuse. And B is what we call the adjacent side, because it is adjacent to it, right next to it. Does that make sense? So the hypotenuse is always the hypotenuse, no matter what. But the sides of the legs, and those are the ones that can be adjacent or opposite. We're going to do the same thing for angle B to show you that it does matter which one you're looking at. I'm going to draw the exact same picture. Well, in fact, I'm going to copy it. And I'll be changing that to me too, man. So here is A, and then B. Now I'm going to do it in, I did it in blue. So for B, in perspective, does everyone have, well, I'll wait for a second to run and draw it. For angle B, the opposite side length is the floor. This is the opposite now. And A is now the adjacent. And C is still the hypotenuse. So it matters which angle you're using, because the opposite and the adjacent change. They flip. But the opposite, the hypotenuse always stays. That's right. So, any questions on that? Yes.
So all triangles in the trigonometric equation are right triangles?
Yes. Yes. Excellent question. All triangles in a trigonometric equation, like for trigonometry, they're all right triangles, because, and this is the cool thing. This is the very cool thing. Because of the Pythagorean theorem, one thing that the Greeks started to look at is they started to look at the ratios between all the different sides. And they started to notice some interesting patterns. And so they decided to call those things names. So the trigonometric ratios. Trigonometric ratios. They noticed, and this is how they were able to make so many great structures, is they were able to use trigonometry to find these things. Not perfectly, they didn't have calculators, but they started to notice some special angles that gave us really nice things. We won't be getting into that aspect of it too much, but we're mainly going to be using it for what it can be used for in the real world. Like I don't think we're gonna do too many real world examples, but trigonometry is very, very useful. Have you ever wondered how those things figure out angles, like different like tools that you find out about? How do they figure it out? They use trig. So a trigonometric definition: a ratio, I guess any ratio, between two sides of a right triangle is called a trigonometric ratio. So we will be studying 3. However, there are technically 6. Yeah. So we'll just learn the first 3, the most important 3, because all the other ones are legitimately just the other ones in reverse. Turn that off. So first one is called sine of angle A or B, it doesn't matter. The way we write it, so sine is spelled S-I-N-E. But when you're using it in an equation, you don't write it like that. You write it as S-I-N, and we say sine, and then sine of A, or it could be B, is equal to the opposite over the hypotenuse. Yes. So, yes, exactly right. This is a sine, everybody, and this is a sine from above. I love trig for that reason. There's so many jokes that you can pull out. The next one is cosine of angle A or B. Which is written COS. We don't write cosine, we write COS, and that's just cos. Dukes. The cosine of A is the adjacent side over the hypotenuse. And the last one that we are studying is tangent of angle A or B, doesn't matter, because you can find the tangent of angle A and the tangent of angle B, is equal to, the way we write it is tan of A, and it's equal to opposite over adjacent. Sorry for all the jokes. I've been going off on a tangent. So there are way too many. There are so many trig jokes. It's the best. I love trig. I wish we could spend more time on it, but actually, so there's a class called Math 127 here, and that is called Pre-Calculus 2, but it's really just trigonometry. you'd spend an entire semester studying trigonometry because there's so much to it. There are so many beautiful results and so many things that get tied together. It's excellent. Absolutely love trig for that reason. There are so many things that you can do. Either way. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. And so just as a small warning, since since different angles have, let's write that have better. Have different opposite / adjacent sides. We need to be careful. We need to identify them each time. If you're curious, by the way, the other 3 trigonometric ratios are just the ratio flipped. So if you do, like, just in case you're curious about the other 3 trigonometric ratios, if you flip this, if you do opposite, hypotenuse over opposite, you get what we call cosecant. If you flip adjacent and hypotenuse, you get what we call secant. And if you flip opposite and adjacent, so you do adjacent over opposite, you get what we call cotangent. But as I said, so as we saw in that picture, depending on whether you're angle A or angle B, your adjacent and your opposite flip. So when you're starting out, always make sure you identify them, and then use the formula. Once you do this enough, you start to just know, like, you don't need to identify it each time. But as you're starting out, it's not a bad idea. Now, the way to remember it, and this is what I'll give you on the exam, but you need to know how to use it, is a remembering trick. Does anybody know what it is? So that's a lot of words to memorize, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is adjacent, opposite over adjacent. How do I memorize that? That's a lot of things. And so the brilliant people thought of a word, not really a word, is SOHCAHTOA. Always reminds me of Squidward when he's superpower and Krakatoa, right? Yeah, with the lava. So SOHCAHTOA, not Krakatoa, but SOHCAHTOA. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. That's what it means. Like, I remember when I heard this, I was like, how is that a remembering tool? But they just said it enough times that you do remember it. So SOHCAHTOA. Mate, what? Sakatoa. It's not like, I don't know, like it's a weird one. There's always like please excuse my dear Aunt Sally. That's a really good one to memorize, PEMDAS. But the trigonometry people couldn't think of a better idea. So this is what we're left with. I will say I'll write SOHCAHTOA on it, so you don't have to memorize SOHCAHTOA, but if you understand how it works. So meaning sine is equal to opposite over hypotenuse, cosine meaning adjacent over hypotenuse, tangent meaning opposite over adjacent. So we're now going to find them. Example, find sine, cosine, and tangent for angles A and B below. reduce fractions where possible. So the triangle given to us, like this. And so it's A is up top left, B is bottom right, C is always the hypotenuse, because C is always going to be the hypotenuse in the Pythagorean theorem. And it says the vertical line, so from A to C, that's going to be 21 meters. The hypotenuse, so the diagonal is going to be 75 meters. And the base is going to be 72 meters. And so, it is the right triangle. Thank you. Thank you. Thank you for calling me out. Appreciate it. That is the one downside of having the iPad, where I can draw these perfectly straight, right? Like these perfectly parallel, perpendicular stuff. So I'm like, oh yeah, well that's clearly a right angle because I drew it and I made sure that it makes the right angle. But so find sine, cosine, and tangent for angles A and B. So let's first find for side A, for angle A. For A, what is the opposite side for angle A? 72. Yes. If you were to draw a line straight out from A, you hit 72 first. Like if we're doing that DVD thing, you bounce. So like maybe the first angle, first side you just hit, then you hit this one, then you hit this one. I love the DVD symbol back in the day. But yeah, so opposite is 72, and then the adjacent must be 21. The hypotenuse is always the hypotenuse. It's always the side length opposite the right angle. So sine of A, by the way, just because I don't think we've ever seen this before, you might have, but the reason why we write like this and we say it out loud, we say sine of A. Later in mathematics, you'll learn about functions. We won't cover them in this class, but functions are really, really, as the name might suggest, fun. So they got fun in the name, functions. But the way we write them is we write it like this, f of x. And so what it means, you don't need to worry about functions, but basically the terminology is you're taking an operation f or a function f, and you're applying it to a value x. And the same thing, you're taking the sine of an angle A. So those parentheses are meant to say this is sine of the value A, of the angle A. That's what that means.
You said opposite over hypotenuse. Isn't the hypotenuse 75?
Yes.
So then why'd you put adjacent as 21?
So I'm setting that up. Excellent question. Excellent question. So I'm setting up so that when we do the cosine and the tangent as well, that we have the adjacent and opposite in front of us. So the hypotenuse is 75, but so sine will be opposite over hypotenuse. So this will be 72 divided by 75. Now, depending on your calculator, it might reduce this fraction for you. My calculator does that for me. And I'm fairly certain any calculator can do it. Any scientific calculator can do it. You just need to know the programming. So if you can't figure that out on your calculator, please talk to me or email me, and I'll be happy to find out for you. Because if you have the other one, the TIXIIS or whatever it is, that one, there is a way to do it. It just takes a little extra work. So just let me know and I will help you find it. But we can do it by hand and say, do we have a common factor here? 72. You can do like, do you guys know about the adding the digits trick for 3? If you add the digits and it's divisible by 3, then the whole thing is divisible by 3. So 7 plus 2, that's 9. That's divisible by 3. So 72 is divisible by 3. 7 plus 5 is 12, which is divisible by 3. So they're both divisible by 3. Really, really cool trick. There's a lot of fascinating ones. There's a lot of fascinating things, and that's in an area of mathematics called number theory. Super cool. But this is 3 times 24, whereas this is 3 times 25. And so how we cancel things is you can cancel things vertically and diagonally. With fractions, you can cancel things vertically and diagonally. So we can cancel this common factor of 3, and this ends up being 24 over 25. Granted, I do think this is somewhat of a more of a parlor trick anymore, since calculators can do this for us. So why spend the time doing it? So you can do it however you want. So once again, if you have the different calculator, or if you don't have that, like, please tell me what calculator you have, and then I can look into it if you're going to email me. But if you want to come in to my office hours or speak to me before or after class, we can also figure it out together. And I would have no problem with you like writing down that programming, like how to do that programming on the exam. So I don't need you to waste precious brain space figuring that out. I'd rather you remember the words to the Big Mac song.
What song?
The Big Mac, not the Big Mac slogan, not the song. 2 all beef patties, special sauce, less cheese, pickles, tomatoes on a sesame seed bun. You know that thing. Like, like this is way, this is probably before your time, but like there was like a rap commercial. There's a rap commercial of them.
What? Oh,
Yeah.
Yeah. So like they like I have that memorized. That is in my head. The song "My Shiny Teeth and Me" from Fairly Odd Parents with Chip Skylark, got that memorized. It's a great song. Did you guys know about that song, by the way? It is exactly 2 minutes in length, deliberately,
Yeah.
because it's you're like the gold standard is you're supposed to brush your teeth for 2 minutes. So it's a great way for kids to learn how to brush their teeth and know how long they're supposed to last. Anyways, I'm sorry, I'm getting sidetracked. Adjacent over hypotenuse for cosine. Sorry for the sidetrack. Cosine ka of SOHCAHTOA. So adjacent in this case for angle A is 21 over 72 over 75. I should probably write hypotenuse as well. Hypotenuse is 75. That way I don't convince myself of doing, let's do things. 21 is also divisible by 3. 2 plus 1 is 3, divisible by 3. But if you plug in your calculator, you should get 7 over 25. And if you forget to simplify it on a homework on a quiz, please let me know, and I can give at least some partial credit back. Like if like they're usually like 1 point problems or whatever, I'll give like 0.8 or 0.9 back. Because that's just a minor step. And last but not least, tangent of A is equal to opposite over adjacent, SOHCAHTOA. So opposite over adjacent, so that's 72 divided by 21, which will reduce down to 24 divided by 7. Okay. Next thing, for B. For angle B, the opposite, the adjacent, and the hypotenuse. The hypotenuse is always the hypotenuse at 75. But now looking at the triangle, for angle B, what is the opposite side? Drawing a line straight out from B, 21. So it just flips. They flip sides. 21 and 72 flip. That's always going to happen, but it's still good to identify them. Once you get comfortable, you can just do, like, the way I do this is I don't write them down. I do them each time. I go sine of B. Okay, sine opposite over hypotenuse, 21 over 7. 75, excuse me. So I just do it by looking at the triangle. That is the way I recommend. But if you needed to set it up in a certain way, if you want it very systematic, do it this way. So sine of B is equal to opposite over hypotenuse. So in this case, for angle B, its opposite is 21 divided by its hypotenuse, which is 75, which does reduce down to 7 over 25. Cosine of B, adjacent over hypotenuse. The adjacent side for angle B is 72 divided by 75, which does reduce down to 24 over 25. And tangent of B, which is opposite over adjacent, in this case would be 21 divided by 72, which is going to be 7/24. I know I did that quickly, so sorry for the rush. Yes. Like vertical and horizontal, is that what you're saying? Yeah, it actually matters not. If like I could give you on the exam or on your homework, I could give you a triangle like that, and it would still be that the is that what you're asking? No, okay. Oh, thank you. It does not matter how you write your fraction line. For sure, yeah. Sometimes like I write them as a slash. Sometimes I write them as a vertical line. It does not matter. Yes, excellent question. I don't know why O over H was the only one I did that for, or over A. Like I did it for sine, I did it for tangent. I don't know why. Do you notice anything that's interesting between the angles A and angles B? They're all the same numbers. Sine of A and cosine of B are the same. You don't need to draw that. And then cosine of A and sine of A are this and sine of B are the same thing. So cosine of A, sine of B. Sine of A, cosine of B. That's why it's co. That's legitimately why they named it co, because there's a like you in formal trigonometry we call them co-functions, because they are like co-parents. They are very similar to each other, and so that's the reason why the Greeks call it cosine, because it is connected. It is related to it. Anyways, any questions on that? So setting up the ratios. The other thing you can do is you can compute the sine of any number, of any angle. So this is something the Greeks weren't able to do because it required a lot of heavy machinery, but I want you to know how to use it. Example, compute with calculator to 4 decimals. Part A is going to be sine of 38 degrees. Now, this brings up an important thing for us. Please make sure your calculator is in degree mode. We are only going to be dealing with degrees in this class. There are 2 different forms of measurement, just like there's 2 different forms of length measurement, right? We can either do the inches, the American way, or we can do meters and centimeters the correct way. There's a thing called radians, and if you want to know what radians are, please feel free to talk to me. But we will not be doing that. We will be doing angle. We will be doing degrees. So if you look at your calculator, it should, like at the very top, it'll either say R or rad or something like that. If you're in radians, then it'll say D or degree, deg if you're in degree mode. To get to it, you usually have to go to setup. So for the Casio that I recommend, you have to press shift and then press the menu button to get the setup. And then your angle unit, you'll press change it, and it says degree radian or gradient. I don't even know what a gradient is, but you want to go to degrees. If you need help changing it, let me know. Well, we can change it after class. Okay. Yes.
What about
What about
Will we
C?
ever solve it for C?
Sine of C, excellent question. Will we ever find sine of C or cosine of C? No, because if you think about it, the hypotenuse is there. So like the opposite side is the hypotenuse. So what is the hypotenuse? Like opposite and hypotenuse are the same thing for it. So you don't really find the trig angles for angle C. Excellent question. Yes. Yes. Or mode. Sorry. So we're gonna do degrees. So now you got C
Thank you.
on your calculator. Anybody else, if you need help finding it, just let me know. Even before, like, I'll probably try to make sure I mention it right before the exam to make sure you convert it to degree mode, because they're completely different measurements. They're related to each other, but they're completely different. So sine of 38 degrees and sine of 38 radians are completely different numbers. The only, say what? So shift mode, so that'll get you to setup. And then you should click, there should be this thing that says degree or deg, and you want that. Okay, did you get it? Okay, excellent. And anybody else, if you have a different calculator, just let me know. The next one will be cosine of 33 degrees. So if you plug that into your calculator, sine of 38 degrees is going to be an irrational number. Sine is only rational for a very few things, and same thing with cosine. So we're always going to get a long decimal expansion. So sine of 38 degrees, you should get 0.6156614 on and on forever. But we're going to round to 4 decimal places this time. Sorry, little guy. So the 4th decimal is that 6. That's the tens, hundreds, thousands. That's the 10,000th place. So looking to the number to the right of it, it is a number larger than 5. So we will round up. So we will get 0.6157 as our answer. Cosine of 33 degrees, you should get 0.838670 on and on forever. Looking at its 4th digit, which is a 6, and a 7 is right next to it. So we will round up. We'll round up to 0.8387. Now, the reason I do that is that I want to go over how you can use trig to, like, you can use angles to solve for side lengths. So if you think about it, so sine, just looking at these ones right here, sine of B is equal to opposite over hypotenuse. Let's say you don't know what the opposite side is, but you know the angle and the hypotenuse. Then you can solve for it because you have one variable. If you have multiple variables, you can't solve. We don't have ways to solve those, but we do have ways to solve one variable equations in this course. So if you only have one unknown, you can solve for it. And I'll show you that here. Example. Find B in this triangle. Right triangle. A is in the top left, B is in the bottom, or sorry, top right, B is in the bottom left, and C is the right angle. And it tells you that B is 32 degrees. And B is the unknown. It tells you 22, and then it tells you C over here. So we can find, it's only asking us to find B, but we could also find C if we really wanted to. We could actually find it in 2 different ways. So once we find B. So. All right. So, oh yes, go ahead.
So, just a example, we can just do it with the calculator.
Yes, yeah, yes, there's only one way to do it for us. There are a few special angles that do have nice numbers that you can compute by memorization. But any other non-nice numbers, the only nice ones are 30, 45, and 60. We can get into reasons why later, but for us, this will be fine. So you'll always use your calculator for it.
In the dinner, we're gonna have. Because like that,
Yes, there will be, and so you'll need to
so
approximate.
we calculate.
Yes, we do. I believe that, I think maybe the calculator that's built into Canvas allows you to do it. I can't remember off the top of my head. But if not, if you don't have a calculator on hand, you can always look, they're like Desmos. Just search Desmos, Desmos Scientific Calculator. And that will provide you with a calculator, like a free calculator application that you can use. And I believe your phone can also do it too. It's just how you enter it is a little weird.
So for, the exam.
Mhm.
Are we able to use the calculator
Yes.
on the computer? Or on the-
No, since it's in person,
We have to get a physical calculator.
yes, I will try to bring, I have two calculators on me, so I can provide two people with that, and then if that person finishes, or like, this is always what I recommend if I don't have an extra calculator. Just finish the problem up until you can't do anymore. And then we just wait until someone hopefully turns it in, you can get the calculator back. And if it ends up being a situation where my calculator is still being reserved up until like the last 20 minutes, then I'll play tag, or I'll play mediator and just bring it to each person.
So for the calculator, we just put sin and 3, right?
Yep, exactly right. Some of them might be a little bit weird. I think you're like, if you use your phone, I think you have to put the angle in first, then press sign. But because some calculators are weird like that. But that's just because the calculator app on the phone is terrible. I hate it because it doesn't follow PEMDAS. It doesn't, for whatever reason. So anyways. We need to use a trig ratio that trig ratio for B, for angle B, that includes lowercase b and another side length and another known side length. Write that down and then I'll explain what I mean there. So we need to use a trig ratio that, like, for angle B, because we're using angle B, that includes B, because otherwise we won't be able to set up an equation that solves for B. If we don't have lowercase b in it, there's no way to solve for B. And then another known side length. So if we knew what C was, we could use C, but we don't. So what trig ratio could use B, and then the only other known side length is 22. So that's in relation to B, what side lengths would those be? What is B? So let me reiterate this one though again. So the reason I'm doing this is I'm going to be setting up an equation. Sine or tangent or cosine, whatever it is equal to something over something. And I'll know if I use a known side length and I know what the angle B is, then I know what the trig ratio is going to be, like what the sine of 32, excuse me, or tangent or cosine of 32 degrees is. I'll know the 22, and then I'll be able to solve for B. So what should we do? Like in relation to B, B is the opposite side. B is opposite. And the known side 22 is what in relation to B? Is it opposite? Is it hypotenuse or is it adjacent? The 22. It's a leg, yes, so it's adjacent. So we're gonna find the opposite and we have the adjacent, which I just said it. Which trig function? Tangent, because SOHCAHTOA. TOA. Tangent involves opposite and adjacent. So
Is that an and sign? It's opposite, sorry.
say what?
Next to the word opposite, is that an and sign?
Yeah, that's supposed to be an and sign. It's not, but thank you. So opposite adjacent implies tangent. So tangent of B, tangent of 32 degrees is equal to opposite, which is B, over adjacent, which is 22. Now, one thing we have to know, and this is how I will solve it, but you're welcome to do it in whatever way you want. Tangent is a number. Tangent of 32 degrees is going to be a number. It's going to be an irrational number. It's going to be a really long decimal expansion. So there's two ways to solve this. Option one, compute tan of 32 degrees, then solve. Option two is wait until the end. So it's your prerogative. I recommend option two. So I'm going to show you option two first. But if you don't like viewing tangent of 32 degrees as a number just in your head, just knowing that it is a number. So it behaves just like any other number. It behaves just like 5 or -2 or anything like that. So tangent of 32 degrees is equal to B over 22. That, right now, you could solve it in two ways. You could either use the cross multiplication trick by treating tangent of 32 as a fraction and then cross multiply, or you could think of it as we need to get B by itself. It's being divided by 22. So all you need to do to get rid of that division is multiply by 22. However you want to do it is fine. Do you guys want to do cross multiplication or multiply by 22? Cross. Sounds good. So cross 1 times B is just B equals 22 times tangent of 32 degrees. Knowing and understanding that tangent of 32 degrees is a number. This will give us the most accurate answer. So then I plug it into my calculator. 22 times tangent of 32 degrees is going to be B equals 13.74712 . And I didn't specify how many decimal places to round to, so let's just round to 2. So this is approximately 13.75. So I'm pretty sure we're just going to finish 1.4 today, and then on Monday we'll do all of 1.5 for the exam. But I will still provide you that little worksheet, and I'll provide the solutions to it if we don't have to, if we don't get to them. Yes.
Can you explain again the part of the 1032?
Right here.
Yes.
So I did in my calculator, I did 22, and then I did multiplication by tangent of 32.
Oh.
Yeah. So tangent of 32 is going to be a number. And so this is why I like this method more, and I'll show you. So same setup. Tangent of 32 is equal to B over 22. I compute what tangent of 32 degrees is first, so that I see a familiar number portion. Tangent of 32, though, is 0.6248693519 is equal to B over 22. And I treat it the same way. I then divide both sides by, I treat this as a fraction by writing it over 1. And then I cross multiply. And so I get B is equal to 22 times 0.6248693519. And if I do that, I end up with, once again, the same thing. I get 13.7471 . So approximately 13.75. I get the exact same answer, which is what we'd expect, right? I'm just solving it a different way, so it should give me the same answer. But I like to do it option 2 purely because I don't have to write as much. And it can be a little intimidating to write such a long number. And that way, the other reason why is that this way I don't have to write an approximation. I get the exact value. The calculator it'll tell you this many digits, but that's not it. The number goes on and on and on and on and on forever. So like tangent of 32 degrees, if you plug that into your calculator, it will give you the most accurate answer. That's the reason why I like that. Okay. Last one. Oh shoot, we got to do that too. On that. Okay. So I will extend the due date of 1.4's homework and 1.5's homework until next week, because we haven't finished all of 1.4, because we still need to talk about the angle of elevation and angle of depression. But we'll get to that. We're going to do one last example, a word problem. A plane takes off from the ground at a 14-degree angle. After flying 15,000 miles, that's ridiculous. 15,000 feet. You can't be 15,000 feet miles into the air. Like going 15,000 miles into the air, you'd be in the stratosphere, you'd be in space. So 15,000 feet, right? After flying 15,000 feet, what is the altitude of the plane? Round to whole number, round to whole number. So this time we're not given a picture. So we're going to have to imagine it. Sometimes you will be given a picture, other times you won't. So imagine we're on the ground and we have our super cool airplane. And it's taking off from the ground at a 14-degree angle. And it's traveling 15,000 feet. So it travels 15,000 feet right here. And we want to know its altitude. So, and by the way, I just realized I should mention this in case I've had it before where if you don't know the terminology mentioned in the problem, like sometimes these problems end up using terminology that we might not know. So if you don't know what altitude is, it's the height. It's how far above the ground the airplane is. So if that ever happens in a problem, you don't know what a word means, just ask. I'm happy to clarify that. That is an answer. That is a question I can answer. I can answer. So we want to know the height, the altitude, x. So in relation to that 14-degree angle, what side length do I want? X, which is the opposite or adjacent?
Opposite.
Opposite. So x is equal to the opposite. And the known side length, we don't know the floor. This is an unknown. So we're not going to use that. We're going to use the 15,000. Is that the hypotenuse, adjacent, or opposite? Hypotenuse. So 15,000 is equal to the hypotenuse. So we have opposite hypotenuse. Which trig function or trig ratio? Sine. SOHCAHTOA. Sine is opposite over adjacent. Or sorry, so opposite of hypotenuse. Use sine. So sine of 14 degrees is equal to opposite x over hypotenuse 15,000. And I've already kept you guys over time. Solve this problem. I'll give you the answer. The answer should be x is approximately 3,629. I don't want to keep you guys any later. Try that one. If you have questions, feel free to ask. Once again, I will be extending the homework. You can do almost all of it at this point. You can do almost all of section 1.4. So I encourage you to try and finish it. The only thing we haven't covered is the angle of elevation and the angle of depression. So we'll cover that on Monday or on Tuesday next week. And then take care of 1.5. Okay, guys?
So the only thing that's due is 1.3.
Yes. But I recommend that you try and do as much as you can. Well, the homework assignments, they don't, they're like, they have a time limit. That's, I wish I could change that.
Can't you?
Say what?
Can't you?
Can you pause the homework assignments?
I don't know.
You can't. Look, I'll see if I can change that formatting thing. It's a weird thing about it. But anyways, if you have any questions, feel free to ask. Otherwise, you guys have a great rest of your day and a great weekend, and I'll see you guys on Tuesday. Sorry to keep you late.